All right, what's up? So I'm Kunal, and I'm going to be going over some code from my project in the Jupyter Notebook. This is the library importation. So we imported necessary libraries like Pandas, NumPy, and Matplotlib, scikit-learn, TensorFlow for machine learning training, deep data processing, and visualization. And then we loaded the data set that we got from an Excel file, and then we sampled 100 random rows from the data set to get an idea of the structure and content. And then we printed out the shape of the data set so we could get info about data types, columns, names, missing values. And then we went ahead and assigned some protocols to uh, classes like web, like HTTP would be a web, Google is a web, Gmail is a web, Amazon Web, and then streaming examples would be YouTube, Netflix, Spotify, and then secure would be SSL based or TLS on HTTP, or HTTP uh, is also in web. And then we created we printed it out to an image so we can visualize it here. And then we made a histogram of the features, and so this was helped us understand which features were important. Um, and then we have um, a heat correlation map. So the heat correlation map helps us identify which features are more correlated with each other. Like the darker the color gets, the more similar certain features are, and we can like merge them into one when we're doing the training. And then um, oh, I forgot to mention, this is important for confirming whether there will be an imbalance in classes. And then also, anything that's blue is not a positive correlation. Gray means like not much correlation. And the redder it is, the more similar. So after that, we converted by force the relevant columns to numeric values. And uh, I just generated a pair plot of the selected features by the category to see which ones match. Um, and from that I learned that say like flow duration and total forward packets have some separation between like say web and streaming, and overall like the histograms show that like flow duration and bytes, things like that, are highly skewed, and we need to normalize some of the features, some of the data, I mean, to have more accurate training. And also, as I said about the heat map, it helped us generate or tell us which features we need to reduce and get rid of them. After that, we have this where we find traffic categories. So we like make a little code to keep track of which one will be which based on like these data types uh, um, from the file. And um, after that is our basically our model training. So um, XDF. So basically here we start with the support vector machine strategy to get a base model done. So basically this will initialize and train a basic SVM model on the training data, and then we want to measure. We use a standard scaler for that over here, and then we train it based off of that over here. And then we want to just get the accuracy. So here we're printing the accuracy out, and then we put a classification report here. And then also we plot a confusion matrix to analyze any misclassifications for each method. So we do this numerous times. We do it in the SMOTE method as well, where we utilize SMOTE for any class imbalance issues. And yeah, we do the same thing, exact thing for here. So it's just copy paste. And then we print out this, we assign a score to each method here so we can keep track of accuracies for testing, and we use a F1 score. And then we print out the results on a visual aid so we can see like what we're dealing with, or like which one's better in terms of when it's running. And then we use a hyperparameter tuning. So we use a tuned SVM evaluation. This will basically over here will evaluate the tuned SVM model with accuracy and a confusion matrix as well. So you can see that over here. And we're utilizing randomized search SV, so we can debug when it's beginning by looking at this message here, and then we call this function to fit the line to fit the classifier and get a result. And we print out the report again, and also we discover the accuracy is 83%. So that's the best one is what I observed, and then we save the disk to a folder, basically. So we saved these models into a folder, and that was basically the rest of them are just like observations and more classification reports for the models themselves, um, and like defining the architecture of the just some other tests where we're utilizing like MLP to compare, but they weren't as efficient compared to the SVM tuning. It was basically the same exact code though, and same exact classification report. And then yeah, this was just to understand um, the training history and like how long it takes. So we just wanted to measure the time. And then this is like an example of like predicted traffic classes. So you can see the number 3, which is web, is the most highest. And then for running the application, this is the code. So it takes in the model and scalar. Uh, it takes in the model and also utilizes scalar for the scalar model, and then we load that into the Streamlit app, and we have a little printout button here saying choose a CSV file. Then we like check is a file uploaded, and if it is, it has to be in the right format, and then we call the variable that has the model loaded, and we apply that to the data frame, and we use this. This is our template to determining which one is which, and usually it is the as you saw in my presentation, the web was the most common, and if it's not valid, then there's an error. And yeah, that's basically my project. So yeah, thanks for listening to this code overview.